Hello, hello.
So, welcome to the interview, CPDC. Uh, so, how are you?
I'm fine, doing good.
Okay, so today we will give you one problem which you need to solve. So, what it says is we have an array of integers and array of requests, and a particular request is of type start and end. That is, start and end represents some indices present on the array, and for each of those requests you need to add the elements starting from index start till the index end.
I
Okay,
think CP Addict C is quite capable to read the problem himself. Why are you reading it?
I was just trying
Yeah,
to explain the problem, but yeah, I rest my case at this
yeah.
You
moment.
are just
Alright.
reading the same problem which I pasted.
I was
I
trying
I
to
mean, if
explain it.
you have something different, you can speak or just shut up.
Okay, we'll talk to the CPD main manager. I will try to make him fire you.
Okay, let's see.
Okay, let me read the problem. You can solve this matter afterwards.
Yeah, currently I'm writing a mail to HR.
I don't care.
CPD, see if you have any doubt regarding the problem statement, please ask any of us. Yeah, you can ask CPD as well.
Yeah, sure.
And this is not 109 plus 7. It
Yeah,
is,
it's 10 to the power 9.
yes, let me write.
What, what the hell you are writing? Oh,
Don't disturb me.
Permutation.
does this format also work in C++?
I don't know.
Okay.
Um, we have to take only one permutation for all the queries, or permutation can be different for
We
every
need to
query.
find out the optimal permutation such that the final sum would be maximum.
Okay, sure.
Yeah, I mean, from all the possible permutations, you have to find one permutation such that the sum is maximum, and you need
Maximum.
not return that permutation. You just need to return the output.
Yeah, and obviously there can be more than one permutations. You need to, if there are multiple answers, you can return any. Like answer would be unique, but permutations can be more than one.
Yeah, yeah, yes.
I think CP Addict, you are high. How
So
can there be multiple answers if we are returning only the sum?
yeah, then I tried to correct myself. I said that answer would be unique, but the way we reach to that answer, the way can be more than one. The ways can be more than one.
Okay, okay.
So one
Let
brute
CP
force,
Addict see
one
concentrate
brute
on the
force
problem.
solution that I am
Okay.
thinking is for every permutation, we can iterate over the request array and find out the maximum sum out of it.
Okay, so that would be a brute force solution. So you are
Yeah,
saying that you'll be trying all the permutations and finding the
yes,
answer, and then
yes,
you'll be finding the maximum one.
Pretty much.
yes.
Okay, very good answer. So can you do it more, fastly?
Yeah, I am trying to think in the same direction. One, two.
And the number of elements can be up to 10 raised to power 5. So 10 raised to power 5. And the values can also be up to 10 raised to power 5. Okay.
Okay.
CP Addict, see, you
Uh,
should keep speaking because we don't know what you are
we
doing. You
can,
might be cheating.
yeah, yeah, yeah. We can sort the request based upon the starting value,
Okay.
Okay.
and then
Mm-hmm.
we can put the array in descending order, but this might not give the optimal answer. But
Yeah, 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 yeah.
in some cases.
Yes, I'm getting what you're saying.
Yes, this could fail in few cases.
Not few, I think in most cases.
Yes. So
There is one
we'll
important
have
constraint which we
to.
need to mention is num psi is greater than equal to 0 as well. I
Oh,
think it does not matter really, or does it, CP dictate?
I don't think it
yes.
matters, but let's say it
Okay.
is always is greater than equal to zero.
Okay.
It might happen that CP Addict C is not very comfortable with negative numbers. So we have to make him comfortable first.
Yeah.
Yeah.
Definitely.
As world is full of negative people, we might be having few of those in this meeting as well.
Yes, and he might be having a suffix called suffix with the second letter of English alphabet.
I really did
Uh,
not understand what you just said, but yeah,
Yeah, yeah.
uh, please give me some hint. I think I'm stuck.
Uh,
I
let's focus on the greatest element. This is the hint for now.
okay.
So let's focus on the greatest element where this element should go.
Um, it should be present in most of the requests.
Hmm.
exactly.
Okay, okay, and
Uh,
then
then the second largest element should be present in most of the requests,
Yeah.
and so on for every number. The greater number should be present in the greatest number of requests
So you can find
possible.
out a greater number just by sorting. Now you just need
Yes.
to make sure that greatest or largest number is being summed up as many times as we can. So we need to do something with the requests factor.
I don't give him more hints, ma'am.
Okay.
He just asked for one hint, and I gave the hint to focus on the greatest element.
Okay, my bad.
Yes. Do you understand that I can complain with the hiring manager that he gave too many hints to the candidate?
I've already sent a mail to HR for your information about you.
Yeah. And do you also know that this meeting is being recorded for quality and training purposes?
Yeah, I do not care.
Uh,
Okay, okay. Well, then let's find out.
for every request, in this I'll have to manage the overlapping intervals as well because the requests might be overlapping.
Yes, you are right. Absolutely right.
So while traversing on the requests array,
Mm-hmm.
but that I will be doing it for every element. Let's say I chose 5, found out that 5 guy gets the maximum element out of the nums array, and for every request, like for the first request, I would be checking that if it's common with some other or not. But how will I maintain the ordering, the permutation, or we don't care about how these this permutation would look like? Only we have
Yes,
to play with some addition of numbers.
yes.
Okay, because I think that I am overthinking right now.
Yeah, did you have coffee before coming to the interview?
No, no, no. I have cake before coming to the interview.
So
I
that's a
had
huge
K.
mistake.
Oh,
Yeah, that's okay.
because
You can do grammatical mistakes here.
It's not okay as far as I am concerned, to be honest.
Who cares about how you care or not?
I care for myself.
Yes, you are selfish. You care only about yourself.
overlapping intervals कितने overlap हो रहे हैं एक दूसरे में?
Are you talking with somebody, CPTC?
No, no, no.
Deduct 5 marks. Let
Yeah.
let me write
I
here.
am just scratching my head and
Let me write -5.
thinking how I would be working with these request array
Yes. And if
because
you see,
there can only be three cases that it's overlapping fully, it's totally not overlapping, it can be sub array that sub subquery that would be overlapped, and if it's totally inside one array, one request, the other request can be fully inside another
Uh,
request.
uh,
CPTC. Yeah. Can I share one small hint with CPTC? CPTC, I'm asking to you.
yes, you can share at this point.
Okay, CPTC, what I want to share is you have these many requests, like request dot size.
Yes,
You want to, and every request is uh, covering some set of indexes, right?
right.
Where we would be adding up the elements. So you need to put the largest element at that index where we are adding that index the maximum number of times.
Okay, wait. Let me give a more clear hint.
Okay.
So the requests can be like this. This is one request, and let's say this is second request, and let's say
Okay.
this is third request, and so on and
I
so
think
forth.
CP Addict 1 is quite fascinated about these making emojis
Yeah,
with these dashes and
he's
dots.
not really interested in giving the hint. He just want to make these useless diagrams.
Yeah, I think he might be confusing me by making these
But
sort of
let me
You
diagrams.
clear it for you. The hyphens signify the requests area which it is covering.
Yeah, yeah,
so
yeah, yeah, yeah. Yes.
so at what index do you think the largest number should be placed?
Mm, this index,
Yes,
It can
or
also be
maybe
placed at this one. Yeah,
yes.
this.
Let's suppose we place
yes,
the largest element here. Then second largest element should be placed where?
the common part in the maximum
Yes.
number of arrays.
Yes. So what we can do is at this index we are having. Uh, let's write it below this one. So at is this index we are having two overlaps, and then two overlaps, and then two. So we are having bunch of twos, and then we have two threes, right? And
No,
then we have a
no,
bunch
no,
of
no.
twos.
I am not able to get what are you writing मतलब in context of what thing you are writing.
So at this index we are having only two overlaps at the zeroth index here
Yes,
and
yes,
here.
yes, yes, yes.
Yes. So think in this direction.
Okay.
Like, if you can only find out this sequence, which is being highlighted right now, then you
Yes.
can associate the number which is having the largest value to the largest
Yeah.
element of our array.
Yes.
So you need to
Okay.
find out this sequence.
And how you can do this?
I can maintain a 1D array
Yeah.
of
Yeah. Now you are going in the right direction.
the
Bingo.
size of the
Well done.
size. बोलने तो दे भाई.
Bhai, he's referring
Oh,
her as
wait.
Bhai. Do you know CPTech 3? Prior to this interview, I'll surely contact HR.
Size num size
Yeah. Yeah. Okay.
because
Now I think you can go ahead with the coding part. So let's
okay.
write the starting function and let's delete this
Oh,
part.
what magic did you just did? I
It
don't
is a
know.
secret. It is a secret trick of Tarun Networks. You need not go into
Okay,
that.
okay. Today
So
I'm
that's
entering with Tarun Networks or Gupta Software.
Tarun Networks.
Okay, okay.
So we have nums and we have vector of int and this is requests. Okay.
Yes.
Now do what you want to do. You are free to do anything. The playground is all yours. Okay.
No,
Like
complex.
CPTech, are you sure he has found out? Yes, he has found out the logic behind the solution, but are you sure he has found out how we can implement it?
No, I'm not sure, but I want to see something because
Okay.
I want to see some code before this interview ends. So that's why I asked him to code.
Fine, fine.
I have initialized a commons array in which I'll be taking down the frequencies.
Yeah, I think he
Yeah,
has
yeah,
figured it out.
yeah, yeah.
Okay,
Okay.
okay. Now, but the number of requests can be
Request dot size.
no. How many number of requests can be there?
It is large. It is very
It is
big.
large. Okay.
Make it large. Roll stack, mega music.
Yeah.
Hmm. Yes, yes, yes. You can do it. Yes, come on. Very good.
Now I'll be checking for a particular column.
Yeah.
Yes. Request I dot first is
Don't disturb CP Addict B.
Okay.
mm, I just have to find the commons all. Request dot first is I'll have to do this for every.
Yes. What are you trying, man? Please tell us something about that.
I'm trying to find the first column commons, then I'll be finding the second column commons, and then
Mm-hmm.
maintaining that frequency in this, and then assigning the numbers to it.
You are assigning the numbers. Have you created this array? till now?
Yeah, this no, I am trying to create that array only,
Mm-hmm.
but I think this would give me TLE, I guess, because
Don't care about TLE for a second. Just go about writing the code.
What a second has been that's like
first
it's over.
second I plus mm,
Uh, CPDC. Have you
yes,
heard? Yeah, you might have heard the term prefix sum.
common prefix
Like
or prefix sum.
yeah, prefix sum.
Yes, I have heard it.
So that was a hint of the
Prefix.
What are you trying to achieve with this if statement?
I am checking the first element of the first row. We have
Uh,
0 to 1, 3. I am checking 0 with 1.
no, I'm not getting. So the idea is to add one to all these indices, right? And then for the second request, we have to add one to all these indices and then these indices, right? Are you
Yes.
trying to do that?
No, I was just trying to do this. Oh, oh.
yeah,
Hmm,
Now,
hmm, hmm.
so
yeah,
Hmm. Yeah, now you are making some sense.
mm, yes. You're going in the right direction.
Yeah, yeah. You are doing good.
now I think now after this for loop finishes,
Mm-hmm.
Mm-hmm.
I would have generated this kind of sequence,
Yeah.
Yes.
and now I have to find out the maximum value in this vector,
Hmm.
and
And how you can do
then
that?
uh, I can do that using searching, linear search, and binary search if the array comes out to be sorted.
You first have to find the largest element, right?
Yes, yes,
And then you have to find the second largest element.
yes.
And then you have to find the third largest element.
I think I can push it into a priority queue, or I can just sort this array.
Yeah. Okay.
So sort commons dot begin
Yeah.
commons dot end comma.
You can. Okay.
So I'll start iterating from the end. as the array would come in the ascending order.
Mm-hmm.
And then as we cannot repeat the array elements,
Mm-hmm.
I'll start putting the values from the end.
Hmm. Okay.
Let's say int answer would be 0,
Hmm.
and then for, and I also, let's say, sorted this array as well, the nums array.
Yeah, exactly.
Okay. Yeah. Now you are on the right track.
Then you just need to map the largest element with the number having the largest frequency.
Hmm. Your voice was weakening, CP B.
I said now you just need to map the largest element with the largest frequency.
Yeah. The size of both would be same. Now this one comma I plus plus answer plus is equals to uh, maximum common. It would be the nums I only
Mm-hmm.
because we have sorted the array in ascending order.
And
For
you have to
every
add this element how many times
oh
in the answer?
into the common frequency multiplied
Wow.
by its frequency, and
Very good.
I'll also do the mod here.
Um, think about it a bit more.
Yeah, yeah, yeah. I think it would be done in this way. And small answer is equals to num size percent mod.
Wait a second. Suppose num psi is 10 raised to power 5 and common psi is also 10 raised to power 5. This value is going to get overflowed because the intermediate result is going to be 10 raised to power 10. But we cannot store 10 raised to power 10 in an integer. Still, we are multiplying these two values.
Okay. So I
Yes.
can take it as long
Yeah.
Okay.
the answer, and as the answer could only be positive.
I think even the modes which are inside this, uh, what do we call them? CP dictate. Which brackets are these?
Round
Huh?
bracket.
Round brackets. Yeah. The modes which are present inside the round brackets are not really needed, like the inside, because the values of common psi and num psi would surely be lesser than mod. So it will always give num psi and common psi. Like we did not need those modes.
Okay.
But see, Sibrick A was saying, okay, yeah, go ahead.
Mm-hmm.
Unsigned log, yeah. You were covering a
What
lot.
I was saying.
Yeah, you were saying, Sibrick C, please listen to me. See this number right here. The value of this can be 10 to the power 5. Are you looking at
Yes. Yeah,
here?
yeah, yeah. I'm looking at it.
And the value of this can also be 10 to the power 5. So if you multiply these terms, it will result in 10 to the power 10, which will overflow. So here also you need to make sure it is not overflowing in this statement.
So what you can do is you can typecast these numbers as well. So you can say that it is going to
Okay.
be long, long, and let's say it is also going to be long, long. And let's remove these. Yeah. Okay.
I've used the defined. Okay.
And
I
you
would also
can do
return.
this.
Okay. And
Now,
return.
why you can keep answer as integer because you are adding 10 raised to power 9 plus 7 twice at max.
Okay. Okay. Yes.
It will always be int, and you are taking
Int.
mod, so it is not overflowing at any point. Okay,
Okay.
and then you don't need this mod. Okay,
Okay.
because last statement is always mod.
Sure.
So I think we are done with this code. So the what should be the complexity of this code?
Uh, for this function, it is being done in linear time, the size of the request. And for every request, I am adding the number of requests into the
Size
request
of
size.
array.
That, yes, maximum it can be the size of array. And
Okay.
for this
So
int
it can,
and log n, it maximum it can be this only for this
yeah.
part. That's
So the complexity is
n into request size.
n cross m. Okay.
N, yes.
So how you can reduce this? Because the only part left is reducing this complexity. You have to somehow make it linear.
Yes, I have read this part somewhere, but I'm not able to recall it. I have done such sort of optimization in one problem where I learned this.
Mm-hmm. Okay.
And
So
by just adding it to the rest of the array, leaving some part.
so are you going to try or you just skipping this?
Uh, no, I'm trying to think of the idea.
Okay,
Uh,
okay.
I'm doing it on my rough sheet.
Uh,
Do it right here.
Okay, okay, okay. I'm doing it.
Let's create some rough part. I'm creating
Yes.
the rough part. So this is your rough part.
don't you think that is pretty big? Like we do not need this much of an area. I'll
Rough
surely contact HR.
part.
I think this is not filling anything.
I think it is
Because,
free.
yes, that's
You
why
can
we are
certainly
using
call the HR. Call the HR right now.
this is the commons. The requests can be this for 1, 2, 0. This would be 0, 1, 2, 3, and 4. And
Yes.
after that, it would be 0, 1, 2, 2, and 1 for these requests. So I can add this. First, I'll do this. And this part to be needs to be optimized. So this could be done. अच्छा, चंदा 0. Let's take one more request here. 1, 0, 1. Here are will be 1, 1, 2, 2, 2, 1. How will be doing P6 now? Time will go.
See, CPD, see, I have
Yeah,
written one example right up here. These are three requests. Suppose these are three requests, okay?
yes, yes,
And suppose the length of our array is 5. So initially,
yes,
your common array would look something like this, as we have initialized it to 0.
yes.
Yeah.
And
So suppose,
after 3 requests, it would look
yeah,
like this.
yeah. Suppose for every request, we have two things: start and end point. So if at
Yes,
start index we do +1, and at index n plus 1 we do -1. Okay, then after doing all this, if you see our array, then for 0 it would be 1, for 1 it would also be 1, and for 2 it would be 0, because here you're adding 1, and here you would be subtracting 1, because you would be doing -1 at the index n plus 1, right?
yes.
And for index 3, you for index 3, please help me out here, CP dictate.
For
You can
index
just
3, it would also be
let's
0.
let's start again.
Okay.
So you
Okay,
have 0, 0, 0, 0, and now first request comes.
Yeah, we can
So
take the request one by one. It would be more helpful.
okay.
0, 1, and then 0 and 0, 0, 1, 2, 3. So we need -1 here,
Because at index n plus 1, we're
At
doing
index, okay, yes.
and we
that's all for the first iteration.
yeah, yeah,
Let me write it for the next iteration.
yeah.
Okay.
Go ahead.
Uh, 0 and the index start, it would be +1,
Yeah.
would be
And yes,
0.
if n is equal to n minus 1, then you do not need to do this part, like n plus 1,
Yeah,
Yes,
because it is not required.
right?
okay. So
Okay,
it
and
would
for
be
the last,
-1. For the last request, 1
Yeah.
and 0, 1. It's
It will remain
ending
1.
at, it will remain 1.
Now we'll be
It
doing,
would be 0.
yeah, exactly.
and rest would be same.
And
Now,
now let's take the prefix sum of the final array. So for taking
Okay,
prefix sum, it will be 1, and
one,
then it will be 2
two,
and 2 and
two,
2 and
two,
then 1.
so
one.
if you see, we have built that suffix array, or that sequence which we're talking about.
So
Okay,
yeah,
yes,
but how does it work? Because we are at each point we are adding 1, and when we'll be applying this prefix search, that 1 will be added to till this index, and it will be
yes.
negated by
At
this thing.
Minus. Yes, yes. So why we are taking at plus one of the end index?
Because we need to add till this point,
Okay,
and
okay,
we need
okay.
to negate it at
Yes,
from this
start
point
and
onwards.
start and end are inclusive.
yes.
So what we
Okay.
can do is,
Let me do it. I am doing it.
yeah,
Uh,
Yeah.
we'll do nums at start.
Commons.
Oh,
man, it should be commons.
commons at start plus plus, and
Yeah,
if end is less than nums dot size,
Mm.
then only we have to size minus 1 because it
yes.
might go to the end index. We'll do
I
commons end is equals minus equal to minus 1.
what the hell you
Okay, okay. So
see? You
leave
needed
that aside.
to do it at the index and plus one. So you should be adding one to
Yeah,
yeah.
yeah, yeah.
Oh, oh,
Okay, okay.
And
And
then I would be taking the prefix sum in
not
common.
inside this loop. You would be doing it after you
Yeah,
have
yeah,
put
yeah.
all the requests.
Yes, 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 yes. I'm doing it.
calm your tits, man. He is samajhdar. He will do it
I'm writing
For
himself.
third mail
if
to the
I
HR.
equals to 1, I less than commons dot size plus plus and commons I is equals to commons I plus commons I minus 1.
Congrats, Asu. You have nailed this interview.
Okay. And
Okay.
whenever I see this word permutation, na,
The time complexity of this loop has been reduced to O of m.
often, yes.
And
So
this part
my
is order of
N.
n.
yes,
So the time complexity is m log m plus n log n.
log n.
Exactly.
Yeah. So that's all for this interview. Now let's move on to the feedback part.
We'll go in the alphabetical order, so you go ahead, CP dictate.
Yeah, but first let me first stop the recording
Okay.
and
What
let
about
me
the extra
let
part for the video? Like, don't you want to say something for viewers?
let me come to this video because it is being recorded right now in the meet. Yes. So at some points I found that you were not communicating your ideas and you were going completely silent,
Okay,
and that might be an issue because we were not able to understand what you are doing, and we are not able to help you and understand are you going in the right direction or not. So that
okay.
was one major issue, and I don't think there was anything else. So CP Addict B, you can go
Yeah.
ahead with your video.
Exactly. I do not have anything else to say apart from this thing. Everything was fine.
Yes.
Yeah.
So